Welcome to this session on game theory under quantitative techniques and operations research. In this session, we will discuss the solutions to the problems asked in the end-term examination of Bangalore University. To start with, we will take the question paper of 2022. There is a problem in question number 6. I will read the problem. Solve the following game by the method of minimax and maximum principle. The payoff matrix for player A and player B is given. In this problem, the number is not given for the strategy. To better understand the discussion, first we shall assign numbers to the strategy. This is optional. So the first strategy by player A, let us say A1. The second strategy by player A, A2. Third strategy A3. Fourth strategy A4. And fifth strategy A5. Likewise, we will name the strategies of player B. First strategy B1. Second strategy B2. Third strategy B3. Fourth strategy B4. Fifth strategy B5. So the playoff matrix is given here. When we look at the payoff matrix, we will first look this matrix in the point of view of player A. When player A is using the first strategy, look at the values, all are positive. That means when player A is using the first strategy, irrespective of the strategies used by player B, player A is going to win. Look at the second strategy. Again, all the values, the cell values are positive. That means irrespective of the strategies used by player B, when player A is using the second strategy, he is going to win the game. Since all the values, all the cell values are positive, we can interpret that irrespective of the strategies used by player B, player A is going to win the game. The reason is all the cell values are positive. Next, if these two players are playing this game, though it is already understood that player A is going to win this game, how player B can benefit by participating in this game? Now player B can minimize his losses and player A can maximize his gain or ensure the maximum possible gains. We will solve the problem, and while doing so, we will discuss some of the theoretical concepts also. The problem itself, it is clearly stated that we have to use minimax and maximum principle. First, we will use this maximum principle for player A. Right. Identify the minimum values for player A when he is using the first strategy. We will calculate the row minimum values, row min values. In the first row, the minimum value is 4. In the second row, the minimum value is 12. In the third row, the minimum value is 22. The fourth row, the minimum value is 16. And in the fifth row, the minimum value is 6. So these values are called as row minimum values. What is the meaning? When player A is using strategy 1, whatever may be the strategies of player B, the minimum gain for player A is 4 points. The second, player A is using the second strategy. Irrespective of the strategies used by player B, player A will gain a minimum of 12 points when he is using the second strategy. Likewise, for the third, fourth and fifth strategies, player A will gain 22 points 16 points and 6 points respectively. Now we will choose the maximum value among these row minimum. What is the maximum value? The maximum value is 22. First we will circle that 22. We will circle that 22. This 22 is called as max min value. It's called as max min value. First we identified the minimum values in each of these rows. Among the minimum values, they have circled the maximum value, which is 22. This is called the max min principle. What player A is doing here? Player A is trying to maximize the minimum possible gains irrespective of the strategies used by player B, because player A do not know what strategy player B will use to win this game. That's why player A is taking a pessimistic approach of first identifying the minimum possible gains, then trying to maximize the minimum possible gains. This principle is called as max min principle. Now we will move to player B. For player B, the payoff matrix, we are looking at this column values. So first we will identify the maximum values in the columns. Column maximum. What does this maximum value mean? We already inferred that since all the values are positive, player A is going to gain points in each of the strategies. What does this mean for player B? It means since all the values are positive, irrespective of the strategies used by player A, player B is going to lose points in this game. Now consider this first column. When player B is using the first strategy, irrespective of the strategies of player A, B is going to lose 6 points. When player A is using first strategy, B will lose 18 points when player A uses second strategy. B will lose 25 points when player A uses the third strategy. Likewise, the entire table can be interpreted in the point of view of player B. So here we are identifying the maximum values. That maximum values are the loss for player B while using a particular strategy. Now look at the first column. The first column is player B is using the first strategy. What is the maximum value? 25 points. When player B is using the second strategy, the loss is 26 points, maximum loss. When player B is using the third strategy, 27 is the maximum value. When B is using the fourth strategy, 24 is the maximum, 28 is the maximum value. And when player B uses the fifth strategy, the maximum value is 22. Here, player B is also taking a pessimistic approach, that is the maximum possible losses when B is not aware of the strategies used by player A. When player B is using the first strategy, the maximum possible loss is 25 points because B do not know what strategy A will choose. So here we are identifying the column maximum. Among the maximum values, identify the minimum value 28, 27, 26, 25, 22. So 22 is the minimum value. Now we will box that minimum value. The minimum value is 22. This 22 is called as min max value. This value is called as min max value. So player B is trying to minimize the maximum possible losses. The maximum loss is given there corresponding to each of the column. And among these values, the minimum value is 22, and that value is called as min max value. Player B is trying to minimize the maximum possible loss. Now we have identified the maximum value and minimax value. We will circle these values in the payoff matrix. So here 22 is the row minimum value. We will circle the value in the payoff matrix. We have circled it. Then the min max value is 22. We will box the 22 in the payoff matrix. So after circling and boxing the values in the payoff matrix, we realize that the maximum value is equal to the min-max value. In our case, it is 22. That means maximum value is equal to the min-max value. When we come across such a situation, the point is called as saddle point. The point is called as saddle point. What does this mean? It means that to maximize the minimum possible gain, player A is using only one strategy, that is A3. What about player B? To minimize the maximum possible losses, player B is using the fifth strategy. When the players are using a particular strategy with the probability of 1, the game is following a pure strategy. So whenever the maximum value is equal to min-max value, it is said that there is a saddle point in the game. And whenever there is a saddle point, the game is following a pure strategy where the players are using one strategy with a probability of 1. Next is we need to find the value of the game. In a game where there is a pure strategy, the value of the game is given by the value at the saddle point. In our case, the saddle point is A3, B5. This is the saddle point. And the corresponding value is 22. That means the value of the game, is equal to 22. Here we also notice that player A is going to gain 22 points. That means player B is going to lose 22 points. When the gain of one player is equal to the loss of the other player, the game is also called as two-person zero-sum game. Here we have two players, player A and player B, and the gain for player A is 22 points and the loss for player B is 22 points. When we add this, it becomes 0. So the game is also called as two-player zero-sum game. So to conclude, first we have identified the row minimum values. Among that value, we have identified the maximum value. Then we have identified the column max values. Among that, we have identified the minimum value. Here we have circled and boxed these values and realized that both are the same value. That is, maximum value is equal to minimax value. The game is having a saddle point. The value of the game is the value at the saddle point. In our case, it is 22. This is how you need to answer a question when it is asked as solve the games. Thank you.